So basically what happen in a fuel cell can also be a source of energy in which the chemical energy changes to electrical energy. What we use as a fuel here, we can use hydrogen, we can use methanol, or we can use ethanol. So fuel cell uses the energy from the reaction and it create a voltage, or basically it is converting a chemical energy to electrical energy. So first, the hydrogen fuel cell. What is a hydrogen fuel cell? Basically a fuel cell, and potassium hydroxide is electrolyte. So we have these electrodes, and one side hydrogen is added, the other side oxygen is added, and when they react with each other, this will result in a formation of water, because hydrogen react with oxygen, it will give H2O. So how it is working of this, like one side we have hydrogen, other side we have oxygen, and as a result, basically what happened, this is the proton exchange membrane. So when it is a proton exchange membrane, what does it mean? It means it can allow protons only to pass through. So when this hydrogen molecule reach this electrode, it will dissociate or break down into hydrogen ion. So hydrogen molecule break down into hydrogen ion by the loss of two electrons. And this is a proton exchange membrane. Proton exchange membrane means it can only allow protons to pass. So H plus ions will pass through the electrolyte. The electrons which are lost by this hydrogen molecule to convert into hydrogen ion, electron cannot move through this electrolyte. This is only a proton exchange membrane. So electron move in the external circuit. As these electrons move in the external circuit, so the lamp will light up or the lamp will be on. And electrons reach the, after transferring their energy, electron reach the other electrode, hydrogen ions from here and oxygen. So when they react with each other, oxygen molecule, hydrogen ion and electron, this will result in a formation of water. So it does not produce harmful gas or greenhouse gas, carbon dioxide. That is why it is useful as compared to other source of energy. And like if we are using a fossil fuel, so we have to burn. Here without burning, a chemical change cause or producing electrical energy directly. So this is a general mechanism of a fuel cell. As a fuel, what is used here, it can be different, and even like this is a basic structure of a fuel cell, then we can modify the fuel cell by using different electrolytes. So example, if you have a hydrogen fuel cell, potassium hydroxide you are using as an electrolyte, and the two electrode potentials are given. What are the two electrode potential? When water molecule gain electron, form hydrogen gas, the electrode potential is minus 8.3, and when oxygen gas reacted with water molecule and take 4 electron, it will form hydroxide and electrode potential is plus or positive zero point 0.4. So which equation, 1 or 2, there is reduction? For which equation a reduction will take place? So equation 2, reduction, because higher electrode potential means spontaneously, or this can happen by itself. Lower electrode potential means this will not happen by itself. You have to change the condition, or opposite is valid. If we want the electrode potential of the cell, the formula to calculate the electrode potential of a cell, it is a reduction minus oxidation. Just remember from redox. So reduction equation 2, because of positive electrode potential, that's why it will have reduction will happen. And or positive or higher electrode potential, not necessarily positive, but higher electrode potential. And for this one, oxidation will happen, and the equation for which oxidation happen means the reverse is possible. To find the electrode potential of a cell, so that is reduction minus oxidation. So reduction minus oxidation, reduction is 0.4, minus is for the formula, and oxidation is minus 0.83. So it will produce, when we solve this, it will produce 1.23 volt. So that is the voltage produced by this hydrogen fuel cell. Now, if we want to name anode and cathode and how to write the overall equation, so how we can write an overall equation for the reduction? For reduction, what is written is the reactant, but for oxidation, the opposite equation you will write. So reduction as it is, you will write, as we have 4 electrons, we have 2 water molecules plus oxygen gives 4 hydroxide ions. And for oxidation, it will be opposite. It will be 2 plus 4 OH, 4E plus 4H2O. So when you solve this equation, because electrons are on the opposite side, so you will add the two equation. As you add these two equation, electron will first make the electron same if they are not same, and just add. The hydroxide will cancel with hydroxide. So what we are left with, and here we have 2 water molecule on the right hand side, 4 water molecule. So as a result, we will have 2 water molecules on the right hand side and 2 hydrogen plus oxygen. So this is the overall equation. And how we will identify which electrode, because basically what happened, hydrogen gas, hydrogen molecule break down and loses electron. So electron travel from hydrogen and it is taken by water molecule and oxygen. Means overall, this is the second equation. So overall is the reaction between hydrogen and oxygen which give water molecule. But basically what is happening, the hydrogen is losing electron. So this is a loss of electron, oxidation, and this is a gain of electron, reduction. So for substance which oxidation happen because there's a loss of electron, so that the electrode is refers to cathode because there's a loss of electron at that point. And the opposite will be anode. So first initially most of the electrons are lost at this point. Electrons like charges repel. If we have a complete circuit, then these electrons start to flow and transfer energy to the electrical component. Is it clear? The hydrogen fuel cell. So you should be able to work out the voltage produced by different fuel cells based on the half equations. We'll do more examples. So example, this was an equation in alkaline medium because potassium hydroxide. But in acidic condition, these are the electrode potential. What are the electrode potential in acidic condition? Acidic condition for hydrogen it is 0 and for oxygen it is 1.23. So when we work out at for acidic condition, you will find we are getting the same answer. So why we are getting a same answer even the conditions are different? The first hydrogen fuel cell was in alkaline condition because aqueous potassium hydroxide. The second fuel cell is in acidic condition and still we are getting the same voltage because the overall equation is same. When the overall equation is same, it is independent of the type of the medium where you're carrying out the reaction. If the final or the overall equation is same, you will get the same voltage. And the voltage, this is the maximum like at standard condition when we have 1 mole, 1 atm, that's 1.23. But as you are using the cell voltage will gradually decrease. So fuel cell will maintain a constant voltage over a time as there is a continuous feed of oxygen and hydrogen. So maintaining the constant concentration of the reactant, this differ from ordinary cell where the voltage will drop over a time. Like example, if we are not able to supply hydrogen here and oxygen, in that case, the voltage will drop. But if we continuously supply hydrogen and oxygen, then it will maintain a constant voltage. Is it clear? The idea of the fuel cell? Because for normal cells, why the voltage drop? The concentration of the reactant decrease. So as the concentration of the reactant decrease, the voltage produced because equilibrium is shifted towards side of the less moles. That is why the voltage will drop. So in this case, as you can see, this is a hydrogen. We can use as an electrolyte, we can use different reagents. Here we are using electrolyte as a potassium hydroxide, but we can also use a proton exchange membrane which only allow protons to pass. So when hydrogen enter from one side, as we know, hydrogen will break down into hydrogen ions and the electron will travel. As these electron move, hydrogen ions, potassium ions are also attracted, but the less reactive will move towards this positive is reference to the movement of electron. Initially, because most of the electrons are here, so this appeared to be negative terminal. An electron like charges repel, so they move to the opposite electrode. So opposite of electron or negative charge is positive. That's why this is refers to positive electrode. But even though it will have those electrons which travel through the circuit, attract hydrogen ion and oxygen from here, result in a formation of water. So using the standard condition, the rate is too slow. So what we do, we apply a high temperature is used to increase the rate of reaction, but the reaction is exothermic. So what it can do, a high temperature, because if reaction is exothermic, increase in temperature shift the equilibrium towards the left hand side, so it will reduce the voltage. To overcome this, instead of we are using like a temperature which will have optimum range, optimum yield or voltage, as well as we are using a high pressure so that equilibrium shifted towards right hand side or forward. Now, what are the advantages of the fuel cell over a conventional petrol or a diesel powered vehicle? Even in Germany, there are buses they designed to use this hydrogen fuel cell. So basically, hydrogen react with oxygen, give water, produce the electrical current. So the whole vehicle is working on electricity. So less pollution and like low carbon dioxide is there. Pure hydrogen, very small amount of air pollutant it is producing, and it has a greater efficiency. But what are the disadvantages? Like what are the limitations basically? Expensive. First thing, you have to extract hydrogen by either reaction of methane with steam or by cracking, thermal cracking of hydrocarbon. Then another problem is hydrogen is flammable, so storage and transport, because transporting a liquid fuel is convenient, liquid or solid fuel, as compared to transporting a gaseous fuel, because if a small leakage is there in a container, the whole gas will escape. So using toxic chemicals and limited lifetime is there, because you cannot keep it for a very longer period of a time. It must be used, or regular replacement is there. So how we store this hydrogen? The hydrogen in a fuel cell, as a liquid under pressure, it is so to maintain a pressure that increases the cost, or absorb on the solid material, or absorb within the solid material. This is how we can store the hydrogen. And production of the hydrogen, we can use electrolysis to produce hydrogen, but the problem is that to carry out electrolysis we have to supply electricity, and electricity, so for electricity we have to use or prepare that, or make that electric generate that electricity from renewable resources. Otherwise, if you use a non-renewable resource, then what will happen? It won't be useful. Instead of hydrogen, because the limitations, as a gaseous fuel, difficult to extract, difficult to transport, store, so we use ethanol fuel cell. So what happened in ethanol fuel cell? You can see the electrode potentials here. Ethanol potential is not given, but the equation is there that what we have ethanol fuel cell which are also being developed. Compared to hydrogen, they have advantages, including ethanol can be made from renewable sources in a carbon neutral way. Like example, we can do fermentation of a glucose, which result in a formation of ethanol. Raw material to produce ethanol by fermentation are abundant, and ethanol is less explosive or easier to store than hydrogen. And because the idea is that use this hydrogen fuel cell, because the working work is done, or the whole research is to develop renewable resources for daily use. Like example, if we are driving a car, so we prefer to have a renewable uh, fuel which we can easily, does not contribute to climate change or global warming. So for that purpose, the research was done on using this hydrogen fuel cell, but because of these limitation and the cost, then switch to ethanol fuel cell. And when we switch to ethanol fuel cell, we don't have to build new petrol stations, because, or the gas pumps. The reason is that because already we are using a liquid fuel, so that can be replaced by ethanol. Now what will be the overall equation? But the difference here, keep in mind here, instead of burning that, we are using the electrical energy, the voltage. Like normally the fuel which we are using, the octane or a petrol, gasoline, we are burning a petrol and then combustion produce heat energy and convert that to kinetic energy as well, and we are driving the car. But here this concept of a fuel, the ethanol fuel cell, means we are not burning ethanol. We try to cause a chemical change which result in a production of electron, and these electrons derive the mechanism of electrical circuit. So the equation occur at the oxygen electrode. What is the equation? This is the equation for oxygen, and the equation that occur at ethanol electrode means ethanol electrode here does not means electrode is made up of ethanol. It means where the ethanol will change. So if you have ethanol water, it will give carbon dioxide, protons, 12 protons and 12 electrons. And as a result, 12 electrons are there, and what happened, the oxygen will gain those electrons and change into water. When we write a combined equation, to make a combined equation, the number of the electron lost by one should be equal to number of electron gained by the other. So here 4 electron, 12. So what, that's why we have to multiply this equation by 2 and add the two equation. So we'll get the final equation, which is also an oxidation of ethanol, that ethanol is oxidized to form carbon dioxide and water. Is it clear? Like why the hydrogen fuel cells are now changed to ethanol fuel cell. Even hydrogen fuel cells are used in spacecraft, but ethanol fuel cells for our use, we can use for generating or driving the electrical powered vehicles. We can use these ethanol fuel cell. Then we have the redox titration. Redox titration means oxidation and reduction when both happen, and we do titration. Titration is basically a technique by which we are finding the concentration of a unknown solution by the help of known substances. We call that as titration. So potassium manganate and iron 2 titration is there. What we do in this titration, so we take a solution in a conical flask and we take iron 2 sulfate. You can take any, like iron 2 can be there, salt aqueous solution of iron 2. So we take iron 2 sulfate. We can find the mass of iron sulfate, or we can find the moles of iron sulfate, or we can find the concentration of this solution of iron sulfate. So how we carry out this in the solution, we have iron 2. Salt is there, but I'm writing only for what happened for iron 2. And we from the Biuret, so what is the color here, the initial color of this? So salt solution is there. Now what happened basically, when this iron 2 ion, we add potassium manganate 7 KMnO4, in which the Mn is 7. So basically the reaction is between the manganate ion and iron 2 ion. So when we add this potassium manganate, so the potassium manganate react with iron 2 ions, it will convert this Mn to 2 plus and form iron 3. So what will be the observation here? The moment when we are adding this, so the purple color will disappear. Why the purple color will disappear? because KMnO4 is purple in color. So the purple, the moment we add, the purple color disappear because it shows that MnO4 with the charge -1 is reacting. Once all of the iron 2 is used up, now no more Mn is able to react, so it will remain or it will keep its own color. So the solution will turn purple. So originally the solution was colorless, but it turned purple, and this is also known as a self-indication reaction. Self-indication reaction means that the reaction in which we are not adding any external reagent as an indicator. Once all of the Mn is used, once all of the iron 2 is used up, the color will not change, so we will have a purple color. Is it clear? Look, in the beginning, you have a solution of iron 2 sulfate. And you're adding potassium manganate MnO4. What happened when you add iron is reacting with MnO4, so there's a reaction, so you don't observe any color change. But moment all of the iron 2 is used up, so you're not left with any iron 2, then the solution will have the color due to MnO4 and it will turn purple. So once the solution turned purple, you can identify that all of the iron 2 is actually used up. So using a ratio between the manganate ion and iron 2 ion, you can work out how many what will be the moles or concentration of iron 2 sulfate solution. So how we can work out using the electrode potentials as well. So choosing a correct acid for manganate titration. Now the acid, because what is happening, this is H plus, from where we are getting this H plus, so this H plus is coming from the acid. So how we choose an acid, we can use the electrode potential concept to select an acid. So some acids are not so suitable as they set up an alternative redox reaction, hence make the titration reading inaccurate. So only what we do, we use a dilute sulfuric acid for manganate titration. And insufficient volume of the sulfuric acid will mean the solution is not acidic enough, and MnO2 will produce instead of Mn2 plus. Because what happened, two reactions are possible. If you remember the redox titration, we have MnO4 with a charge -1. We want to convert this into Mn plus 2. So what will be the balance equation? To balance oxygen, we add water. This is what we did in AS. To balance hydrogen, we add protons. And to balance the charge, I will add electron. So how I will add electron? Because +8 and -1. So the total charge is +7 here. And here the total charge is +2. So I can add 5 electrons so that the charge on the left hand side is equal to charge on the right hand side. So this is a balance equation for Mn, the conversion of manganate ion into Mn plus 2. But what happens if we have small amount of acid, if small quantity of acid is used, then what you will observe, instead of Mn2 plus is produced, it will produce a solid manganese 4 oxide. So not insufficient volume should be there, otherwise solid manganese 4 oxide is produced. And the brown manganese 4 oxide will mask the color change and leads to greater inaccuracy of a volume of manganate being used in the titration, because then you have to add too much manganese uh, for to carry out the titration, so it will not be accurate. And using a weak acid such as ethanoic acid will have the same effect. It cannot supply a large amount of hydrogen ion, like 8 protons. So if it cannot supply a large amount of hydrogen ions, then possibility is there this reaction might occur. Manganese 4 oxide can produce instead of Mn2 plus. So the reason why dilute sulfuric acid is used, though these are the reasons, but it cannot be concentrated HCl. What is the reason why it cannot be concentrated HCl? When you check the equation for manganese for conversion of manganate ion to Mn2 plus, the electrode potential is 1.51. And for chlorine molecule to convert into chloride ion, electrode potentials are always given to for gain of electron. It is 1.36. So for which electrode potential is higher? Which one reduction happened, for manganese or for chlorine? So 1.51 and 1.36. So this will be reduction and this will be oxidation. So basically what happened if we add a hydrochloric acid, so if we add hydrochloric acid, these chloride ion, because if this happened reduction, so equation 1 remain as it is. But equation 2, what will happen, because it is oxidation, so opposite will happen. The chloride ion, when two chloride ions are there, they will give two electrons and give chlorine molecule. So and from where this chloride ion is coming, it is from hydrochloric acid. So if we use hydrochloric acid, so basically the reaction between hydrochloric acid and potassium manganate or will occur, or manganate ion will occur. So that's why, so hydrochloric acid will react with manganate as well, and manganate should also have to react with iron too. So what will happen, we need a greater volume of manganate ion. That's why it is not suitable. Second thing, it also gives chlorine gas, which is toxic. Is it clear why hydrochloric acid cannot be used? Is it clear the reason why the HCl or hydrochloric acid cannot be used? Because the chloride ion will from HCl will form a chlorine gas, and because there is a reaction between them, so that will result, some of the manganate ion will react with hydrochloric acid, the chloride ion from hydrochloric acid, and some of the manganate will react with react with iron 2 ion. That will leads to higher volume of manganate ion required for this titration. And it cannot be nitric acid as well. Why it cannot be nitric acid? As it is an oxidizing agent. So what the nitric acid will do, basically nitric acid will react with when you check the electrode potential, this is the electrode potential for nitric acid, basically nitrate ion, and from where we get nitrate ion, from nitric acid. So electrode potential is there, 0.94. An electrode potential for iron 3 to take electron convert 0.77. So for which one reduction happen? For nitric acid, nitrate ion reduction happens, so this will be oxidation. So what happened? This equation remain as it is, but for which oxidation occur, means opposite will happen, that iron 2 ions will lose their electron and convert into iron 3 ion. So in the solution, the amount of iron 2 ion will decrease, because if the nitric acid is present, so nitric acid will reduce the amount of iron 2 ion And as it reduces the amount of iron 2 ions present, so we need a smaller volume of or smaller amount of manganate ion. So not we cannot use concentrated hydrochloric acid, we cannot use nitric acid, we cannot use small amount or quantity of sulfuric acid, or we cannot use any di weak acid. It should be dilute sulfuric acid, but sufficient amount to make sure it supply enough protons for this change of manganate ion to Mn plus 2. Is it clear? The titration of iron manganate ion with iron 2. So a simple example is there. You have 2.41 grams of nail made from alloy containing iron, which is dissolved in 100 cm cube of acid to form iron 2 ion. 10 cm cube of a solution was titrated with potassium manganate of concentration 0.02 and 9.8 cm cube is needed for a reaction. What is the percentage of iron by mass in the nail? So first thing, we'll find the moles of manganate ion. Concentration into volume 0.02 into volume is 9.8, but that is in cm cube, so we have to convert into dm cube. So that's a moles of KMnO4 or manganate ion, because KMnO4 will dissociate into K plus and MnO4 minus. So the ratio between Mn and iron 2 is 1 is to 5. So 5 moles will be there for iron 2, like 5 times the moles will be there for iron 2. And after getting a moles, but these are the moles of iron 2 in 10 cm cube, because we were having a solution of 100 cm cube, but we did not take all 100, we just only take 10 cm cube and titrate it. So in 100 cm cube, the moles will be 10 times. That's why it is multiplied by 10. And to get the mass of iron, so moles multiplied by molar mass, iron is 55.8, so we'll get 0.547. And this is a mass of iron. So to get the percentage by mass of iron divided by mass of the nail multiplied by 100. So this nail contain about 22.6% iron. Is it clear? For everyone? Yeah. So we'll continue this. I'll share another link with you.